Hello everyone, welcome to another video, where today I would like to talk about a couple of things that happened in the debate between FTFE and Real Offended, where Ross from Real Offended, the flat earth side of the argument, has said quite many things. A lot of them would bear their own video response, but they don't have that time or that will to dig through that much flerf talk. One of the things that he said, however, and that I found interesting, was this statement right here. That the Copernican principle, or like our supposition of it, could be gotten rid of by taking what's called a underdense region, kind of a void that our system was in, and that the matter density is low compared to the rest of the universe. And so then some of the observations that could be accounted, that we take as evidence for dark energy, could be accounted without the need of doing so, right? And let's just briefly say what Ross has to say about it.
So this is one quote of about 100 I have of different people.
And what has that got to do?
How there is an equivalence between the two. The only thing
there's nothing there that says there's an equivalence.
The Copernican principle.
There is nothing there that says there's an equivalence with the neotectonic. Nothing there at all.
Yes, it does. It's describing.
No, it doesn't.
Supernova specifically.
That's nothing. Supernova has nothing to do with the neotectonic model. You just.
Whilst I agree with Craig here that certainly this gentleman has nothing to say about any kind of neotectonic model, what Ross is trying to claim here, but I find it nonetheless interesting that there is such a thing as an alternative to the Copernican principle. Now, in true flat Earth nature, Ross has not. I mean, he did list the source where he had it from, and it was, as far as I could figure out, correct. So that's good. The issue is he did not look at the paper in any more detail, of course, and the later papers that came out that are talking about this topic very much disagree with him and with the things he says about the Copernican principle. Somewhat unsurprisingly, I believe it was MC Toon's first law of flerf is that the sources always disagree with what the flat earth is trying to use them for. I'm afraid this is correct here. So let us have a brief look here. This is the paper that Ross here cited. This is the guy that he has on the thing here, and who is also citing here, Timothy Clifton. And so, in principle, what this paper does here is that it suggests, or it gives an alternative explanation to our observations, right? Because the Copernican principle is based upon the fact that, or upon the supposition that the Earth, or the solar system, is in a region of the universe that is more or less just like any other region of the universe. There is nothing particularly special about it. The matter density is about the same that it is at any other place. There is no kind of preferred direction where there is more stuff. There is no direction where there is less stuff. On average, like on very, very, very big scales, that's important here. We're not talking about stellar scales. We're talking about galactic and supergalactic scales, extra galactic as they're sometimes called, scales. And so, on the one hand, the observations that we have since the 1930s, they kind of build upon the supposition that the Earth is in no special place. Because if we assume a special place, we can kind of make up anything, right? And in the last 20, 30 years, a couple of counter-hypotheses has come up. For example, the one that is explained here. Note that this paper is not advocating for it, it's just explaining how it would work, right? Where they say, for example, well, if the Earth, or if the solar system was in a region of space that was particularly empty, some of the observations that we see and take as an indicator that the universe is expanding could be explained without the universe expanding, and thus without dark energy. That's kind of what's going on here, right? And they go through the whole mathematics with a whole bunch of stuff that is rather well too complicated to explain it in in this context here. But the last paragraph here is important. Two very different paradigms have been invoked to explain the current observations of an apparently accelerating universe, depending on whether we invoke or reject the Copernican principle. We have shown that in the coming years it will be possible to experimentally distinguish between those two scenarios, allowing us to experimentally test the Copernican principle. And that's kind of the thing. At the time, this paper came out in 2008. The experimental or like the observational capabilities were a bit lacking in that regard. So I dug out not one, not two, not three, but 4 papers that actually do that, you know? And I would like to say here, Ross, you are on the wrong side of this argument here. First of all, we have this lovely paper here, which is the literally titled from 2011, The Confirmation of the Copernican Principle at Gigaparsecs Radial Scale. Oh well. Confirmation, extremely important. The confirmation of the Copernican Principle. When we go down to the conclusion, where it says, let me briefly look through it. I'm sorry. Well, they say that there are some other hypotheses that could technically work. Their overall conclusion is that the Copernican principle stands, right? Yeah, we conclude that any adiabatic void models capable of explaining the supernova Hubble diagram would likely generate too much of that's the Sunyaev-Seldovich effect. I can't explain it right now, but the conclusion here is this strengthens the evidences for cosmic acceleration and dark energy. So here I have a paper that was released 3 years after the original paper from renowned astrophysical and astronomical institutions. That's one paper. The second one, a test of the Copernican principle. Again, from usual academic institutions, even from before the original paper. When we go down to the conclusion, now I would encourage you, if you're interested and if you have ideas about the whole topic, to read through them. If not, they are technically pretty heavy, as you can see from the absurd amount of mathematics. The results rule out large voids with large density contrasts. The most egregious violations of the Copernican principle. So, they say that, well, likely, the results that they get for whatever they were doing, is that no large voids, as this paper here lists as an alternative, can be found with what they say, although they mention that small voids are technically still possible. Right? What they were doing is they were observing the cosmic microwave background with kind of a special method to try to figure out how it should be. It's an interesting paper. I would recommend you read it if you're interested in that thing and if you can bear with the mathematics. Then we have complementary consistency tests of the Copernican principle via Noether's theorem and machine learning forecasts. Again, from reasonably renowned astronomical institutes, or in this case, physical institutes. In summary, we have presented a new consistency test of the Copernican principle, which is complementary to blah, blah, blah. In particular, we use the Noether's theorem. Noether's theorem is named after Emmy Noether. I believe she was German. A theoretical physicist, who was quite important actually in the early formalization of theoretical mechanics, like a bit after Newton. If he did something with physics, she's like on the same level as Hamilton or Lagrange and those people. To conclude, blah blah blah. They essentially list that it is possible for us to test this now, and they even say up here above that this method is kind of sound, right? I believe this was the paper that was more or less. I could be mistaken. Yeah, they rule out here several models that disagree with the Copernican principle. So we rule out several scenarios based on the Lemaitre-Tolman-Bondi void model. So they rule out void models in this paper. Again, no void. Don't find any problems with the Copernican principle. And the last one, which I liked in particular. In addition, the Copernican principle itself was tested at the gigaparsec scale using spectral distortions of the CMB spectrum with the antikinetic Sunyaev-Seldovich effect, which was the KSZ from an earlier paper. These analyses rule out the adiabatic void model, where we live in the center of a large gigaparsec void as an alternative to the existence of dark energy. So, what do we, again, from 2016, from a whole bunch of renowned institutes for physics and astronomy. So, and I expect all of his other citations to be something like that or to be misunderstandings, as actually happens later in this debate. Now, Ross, the next time you go quote mining, just don't take the first sentence of the abstract, will you? Because that's what you did. That's very poor. A fundamental presupposition of modern cosmology. Oh, well, look at that. That's not how you do that, Ross. Come on. At least pick a sentence from the introduction, but I imagine you got afraid because the introduction includes weird signs that you don't know, right? Or maybe go to the conclusion where they say that it's not a fact, it's just they're putting another model out that at the time, 2008, made similar predictions, right, than the usual model with the Copernican principle. So, and you didn't do any follow-up research, right? You picked a paper that came out over 15 years ago and you just say, oh, it says what I want, or it kind of suggests that maybe this is a thing without doing like the follow-up research. It cost me about an hour to find the other 4 papers, and I read parts of them because I found them interesting, even though I'm not that into cosmology at all, right? So, Ross, please. I can't, if what I just said didn't convince you, I don't know what will. I imagine probably nothing, but yeah, very, very, very poor example, and just bad quote mining on your part there. But I think I'd leave it at that. Enough suffering for today. Yeah, if you enjoyed that, maybe consider leaving a like. If you didn't enjoy it, feel free to leave a dislike or tell me in the comments why. If you enjoyed a lot, maybe considering subscribing. And with that, I will see you in the next video. Have a nice time until then. Goodbye.